Welcome to T2, day 27 of calculus. We're going to go back to fencing problems, but in this case we're going to introduce the idea that certain fencing will cost a certain amount and other fencing will cost a certain amount. So in this case we want to fence in exactly 2,000 feet squared. So let's label some things here. Let's call it the width. So we have width over there as well. So that immediately tells us that the area is length times width, but we know it has to be 2,000. So we know 2,000 is equal to length times width. Find the dimensions that will minimize cost. So if we're minimizing cost, we need an equation for cost. Well, how much of the fencing that costs $3 per foot do we have? Well, we have 2W of that. So the cost of that fencing is $3 per foot. So that's the cost of the fencing that's $3 per foot. And what are we adding to it? We're adding to it L feet of $7 per foot. So that's 7 times L. So that tells us that the cost of the fencing will be 6W plus 7L. We want to minimize that value, so we want to take a derivative, but before then we need it to be in one variable. Well, we know from this equation right here, if we divide both sides by L, that 2,000 over L is equal to W. So we can take that and plug it in right there. And now what do we have? Cost is equal to 6 times 2,000 over L plus 7 times L. It's in one variable. Let's simplify it a little bit. So we have 12,000 over L plus 7L. And let's rearrange it a little bit to make it easier to take the derivative of. So it's 12,000 times L to the -1 power plus 7L. Now let's take a derivative. If we do C prime here, we end up with negative 12,000 times L to the -2 plus 7. Now we do what we've done many times before, which is set it equal to 0. So 0 is equal to negative 12,000. And L to the -2 is 1 over L squared plus 7. So let's add this to the other side. So that means it's 12,000 over L squared is equal to 7. And I'll make it 7 over 1. So let's cross multiply. 7L squared is equal to 12,000. So L squared is equal to 12,000 over 7. And you might assume that this doesn't have a very nice solution, and it doesn't. So you can use a calculator, and L will be, you can round it to 41.40. So now you do a sign diagram where you have L in the middle here. Not L, but it's an L value of 41.40. That is an L value. And then you have the cost derivative, the change in cost. So we know it's 0 there. But what you find out is when you plug into the derivative, which is right here, plug in a number to the left of 41.4, it's negative over here, and it's positive over here. So that means the cost is going down and then up. So that we've just verified that it is a minimum. So the minimum cost occurs when L is 41.4. But this question is asking for the dimensions. So we need to find W. But we know that W is equal to 2,000 over L. So you do W when L is 41.4. So it's 2,000 over 41.4. And you find out that it's 48.31. So the dimensions that will maximize the error of 41.4 by 48.31, and both of these are feet right there. So we found the L value that made the derivative 0. We verified that the minimum occurs there for cost, and then we found the